Okay, so I will be discussing my literature review on nanofabricated supercapacitors and 6 different sources that I summarized in my review that talk about using a different type of nanomaterial for a supercapacitor. So the reason why I chose to talk about supercapacitors is because there's a need to advance current energy storage devices. So energy storage devices, like batteries, lithium-ion batteries are like the most commonplace and widely used energy storage device today. So they play large roles in our lives, but there is a demand for more environmentally friendly, cheaper, and more efficient ways to store energy rather than just using a lithium-ion battery because they have low power densities and inefficient cyclability. And also, lithium is a non-renewable source, so we don't have like an infinite supply of it. And lithium-ion batteries are also non-biodegradable, so they can leak hazardous waste into groundwater or landfills, which cause like a bunch of issues. However, these shortcomings can be fixed by incorporating nanomaterials that have really unique properties into supercapacitors. So in order to understand supercapacitors, you also have to understand capacitors and batteries. So batteries are usually store their energy chemically through a chemical reaction. So in the case of a lithium-ion battery, you have lithium ions traveling from the anode to the cathode. And because chemicals are very energy dense, you end up getting a very high energy density but a low power density. And so energy density is the amount of energy per unit volume, and power density is the measure of output per unit volume. And so capacitors store their energy electrically, which means that you have ions moving according to an electric field, which gives you a really high power density but a low energy density because you can't store a lot of energy electrically. And so supercapacitors kind of bridge this performance gap by utilizing nanotechnology, which achieve both a high energy density and a high power density. So I can't go into much detail in the video, but I do go into a lot more detail in my literature review. So my first and second sources basically talk about utilizing something called cellulose nanofibers and HZs, and a composite of the two to create an electrode material. And the second source talks about using a 2D nanomaterial called dimetyl carbide, which is shown on the right here, also as an electrode material, and they both achieve very good specific capacitances, and their numbers are on the screen. So my third source talks about using a type of magnetic metal oxide called a spinel ferrite, also as an electromaterial, and they have really high energy densities, durabilities, good capacitance retention, high power, and effective long-term stability. And so spinel ferrites use a charge storage mechanism called conversion reactions, and I talk a lot about this in the review. And my fourth source talks about using a carbon-based material, which is arguably the most famous type of nanomaterial, which has an extremely high mesoporosity, giving it a large surface area and therefore increasing the energy density and overall capacitance. And so the energy storage mechanism of a carbonaceous material basically has to do with the potential difference between the inner Helmholtz layer and the outer Helmholtz layer, or the Goury-Chapman layer, which is showed in a diagram on the screen. Last sources talk about using carbon nanoflakes as a type of electrode material, and they have a 72% mesoporosity, so that means like the majority of it is porous, which creates a type of supercapacitor that achieves a really high energy and power combination. And so the capacitance numbers are on the screen, and something that I thought was really cool about this is that it showed a charging time under 3 seconds, which are some of the highest ever recorded. So a few challenges of doing this review. I noticed that it required like a lot of background knowledge, so I spent a lot of time doing research in order to understand the content that was being conveyed in the papers. And the papers were also written for an academic audience, so like they used a bunch of big words that I had to look up sometimes. Another challenge was I had to summarize like an entire paper into one paragraph, and so you kind of have to decipher like what details you can leave out without compromising the content of the paper itself. But I also learned that there's like so much room for improvement and innovation in energy storage, and there's a lot of potential in this field.